So we've seen that when we have the equation of an exponential function in this form, that we can transform the graph, or it will be transformed in this way. The A is going to change the steepness or flip the graph. That B value is going to change the rate of growth, whether it's growing up to the right or decaying down to the right. The H is going to move left and right. The K is going to move up and down. So now let's see how that applies to this graph here. So we want to graph y equals 2 to the x plus 3 minus 5. So first we want to figure out how it differs from the graph of y equals 2 to the x. So y equals 2 to the x, we kind of know what that graph looks like. All right, so hopefully we can kind of know. Maybe a little steeper than that. Something like that. So we know this graph will move that plus 3, that's in the H spot. Since it's positive, it's going to move left. So this is going to move left 3. And then we've got this 5 minus 5. That's in the K spot after the exponent's performed. And that minus is going to be moving it down. So this will be down 5. So we now know that the graph will move left 3 and down 5, so now we can graph it. Now, we can think about 2 to the x. 2 to the x goes through 0, 0, 1, 2. 2 to the second is 4th. 2 to the third is 8. So on and so forth. Okay? So that's our graph of 2 to the x, and then it goes down here, and it gets halved, a quarter, an eighth. Okay, and we have a horizontal asymptote on the x-axis. Okay, now if we move the whole thing down 5, that whole horizontal asymptote is going to go down 5. All right, so go down 1, 2, 3, 4, 5 to negative 5. That's where our horizontal asymptote is. It's a good idea to draw in the horizontal asymptote, just a dotted line. That's not part of the graph, but that's our new floor. It's going to be the same shape as 2 to the x because the base is 2, but the whole thing is going to be left 3 and down 5. So we know it's down 5. Normally, it goes through the point 0, 1 right there, right? Okay. However, that point's going to be left 3. That point's going to go left 3 and down 5. So that point's going to end up here. Now, we can always, don't forget, okay, if we lose you along the way here, you can always make an XY table and plug in some points. Just plug numbers in and crank them out. That always works. However, knowing how this moves, we can come down here and we can say, well, this whole thing is moving left 3. So I'm going to take this axis and I'm going to move it left 3 to give me a new reference point. And I'm going to put a dotted line, or at least imagine this axis coming over here. So now this is like 0, 0. That's not part of my graph, but now instead of graphing here, now I'm going to be thinking, okay, let me graph y equals 2 to the x, but let me graph it from this blue axes here. So if we imagine these are our axes here, then when I graph 2 to the x, now I'm just thinking 2 to the x because I want it to look like this green curve. Well, using my blue dotted axes here, 0, 1 would be right there. That's not really the point 0, 1. The true 0, 1 is up here. This is my new 0, 1. And then I know that when I graph 2 to the x, I go to the point 1, 2, because 2 to the first is 2. When I graph 2 to the second, when I go from the origin right to up 4, I'll be right there. Okay? Get that out there. Okay? So these blue dots are my new graph. Now, is that blue graph the graph of 2 to the x? No. That blue graph is the graph of 2 to the x plus 3 minus 5. That's really what we just graphed, x plus 3 minus 5. Okay. What happens as we go to the left of this starting point? Well, it gets cut in half, a fourth, an eighth, and there it is there. As it gets closer to this asymptote of negative 5. And so there's the graph of x plus 3 minus 5. Okay, this blue graph right here. So that's how we do it. We kind of imagine that the whole thing moves, and it's useful to kind of focus on the starting points here. So this starting point moved down to here, and it's useful to kind of draw these axes. Definitely you want to draw the asymptote, which is like the new x-axis, and the vertical axis is like the new y-axis. Notice the vertical has moved over 3, that's the plus 3, and the horizontal axis has moved down 5, that's the minus 5. Let's try one with a fractional base of 1/3 here. Okay, so, well, we want to compare to y equals 1/3 to the x. 1/3 to the x, well, that's going to go through 0, 1. And this is going to go up to the left 3. We'll go left 1, up 3, because 3 to the first power is 3. 3 to the second power is 9. So left 3, up 9. We're thinking about the reciprocal of this. As we go to the right, 1/3 to the first is 1/3. 1/3 to the second is 1/9. 1/27. So there's the graph of y equals 1/3 to the x. Now, that's not the graph we're going for. That's why I just kind of did it lightly and dot it. We want to take that graph and move it. What's the minus 2 going to do? Well, the minus 2 is going to go right 2. Remember, this is backwards. So right 2. And the plus 1, that's the outside. That's in that K spot. That's going to go up 1. So this whole graph is going to move up. This graph has an asymptote of the x-axis. Our new graph will have an asymptote at a height of 1. Because the asymptote moves up 1, the whole graph moves up 1. This reference axis, this y-axis, is going to move right 2. All right, so everything's going to move right 2. Now you can do this 2 ways. Let me show you 2 ways to do this. All right, and you pick the one that works well for you. Now going back to the non-translated graph, we got this point at 0, 1. We've got this point and this point. Okay, that point is at 0, 1. This point is at negative 1, 3. This point is at negative 2, 9. Now, if you want to, once you realize you're moving right 2 and up 1, right 2 and up 1, we can keep those numbers in mind. Right 2, up 1, right 2, up 1, right 2, up 1. Okay, here we go. Let's take each of these points. Right 2, up 1. There it is. Take this point, right 2, up 1. There it is. Take this point, right 2, up 1. There it is. Okay, and that's good enough there to get our graph, and it's going to go down towards our asymptote here. That's great. Okay, so if you graph the parent function, y equals 1/3 to the x, and then just count right up, right up, right up. Move all the points the same direction they're supposed to go. You'll get your new points. Okay, that's a good way to go. Okay, now another method here. Let me erase that real quick here. The other option is this. We know the whole thing goes right 2. So I'm going to take my axes and I'm going to move that right 2. Okay. I'm going to take the axes right 2. Now, this is just a reference. So I'm just going to put a little dotted line for myself. Okay. Now I haven't changed the coordinates. This is still 0, 1, 2, 3, 4. This is still 5. And this is still 1, 2, 3, 4, 5 on the y-axis. And 1, 2, 3, 4, -5. Those numbers are, the axes didn't change, but where I'm graphing has changed. So this reference point on this light green, y equals 1/3 x, which was at 0, 1, well, now I'm going to pretend in my mind that this is the origin right here. It's not, but I'm going to pretend for a moment. Because if that was the origin, and if I was graphing this equation here, but now I want to graph it from here. So I'm going to ignore the black lines. I'm looking at those dark green dotted lines there. And I think, okay, if this was the origin, then my curve would go through 0, 1. My curve for y equals 1/3 x. It would go through 0, 1. And then, since this is 1/3, it's decay. It's going down to the right. I'm going to go up to the left 3. 3 from my axes here. Left 1, up 3. Okay. From my little pretend origin, my translated origin, I'm going to go, well, 2, 1/3 to the second power, or -2 actually would be like 3 to the second power, which would be up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, did I not count far enough? You know what? This one, you may have caught that. I think this one's too low. 5, 6, 7, 8. I think it is. Okay, so this point should have been up higher. So, anyways, this point actually should have been up here. All right. And so this point's actually off the charts a bit. Okay, and then going to the right, we're going down to 1/3, 1/9, so on and so forth. It's getting closer to this dotted asymptote. And so this is a graph of y equals 1/3 to the x. It's moved right 2 and up 1. Okay, which is what we were trying to graph all along. Ooh, yeah, that's right. Okay, so the 2 ways to go there. Now, there's a third way always, okay? Don't hesitate to, if you're stuck, you can always just plug in x values and find y values. You can plug in 0, 1/3 to the 0 minus 2 plus 1. This is like 1/3 to the -2, which is 9. 9 plus 1 is 10. And then you could plug it in for 1. 1 minus 2 plus 1 equals, all right, and work that out. Okay, when x is 1, you're going to get 4. Because this is 1/3 to the -1, which is 3, plus 1, which is 4. And that point, 1, 4, is right here. The point 0, 10 is up here. Okay, so there's 3 different ways to go. If all else fails, do the table of values, but if you can use the transformations to slide it over and up, that's best.